In this section, we're going to talk about expectation and the standard deviation of probability distribution. So we talked about sample mean, and the sample standard deviation before. And the sample mean is the average. We add all the numbers up and divide by the number of numbers we have. So, for example, if we have 10 numbers, we toss a die is tossed 20 times, we get the following data. So first time we got 4, and second time we got 3 and 4 and 2 and 5 and so on. So 20 times. If we want to find out the sample mean, or you can call it the average, and we add up all these 20 numbers divided by 20. So if we add all these numbers, we get 76 and divide by 20. So the average is, or you can say the sample mean is 3.8. But there's another way we can calculate a sample mean. We didn't talk about it before. So instead of adding all of them up, divide by 20, we can find out, say, like how many ones we have. So we have 2 ones, and we have we have how many 2's, and we can find out we have 5 2's. So here and here, we have 5 2's, and we have 1 3, we have 4 4's, and we have 3 5's here and here and here, and 5 6, and we have 5 6. And so the way we calculate 76, of course you can do 4 plus 3 plus 4 plus 2 plus 5 plus 1 and so on. You can also do 2 ones, so 2 times 1, 5 2's, so 5 times 2, plus 1 3, plus 4 4's, that's 4 times 4, plus 3 5's, that's 5 times 3, and plus 5 6, and that means plus 5 times 6. So because we have 5 6, and that you can also get 76. And we can also split it, say 1, the number 1, what's the relative frequency? Or you can say what's the probability of getting a 1 here. The relative frequency is we have 2 ones, so 2 out of 20, that's the relative frequency, and a 2, that's 5 out of 20, so 5 2's out of 20 numbers, and 1 3 out of 20 numbers, and 4 4's out of 20 numbers, and 3 5's out of these 20 numbers, and 5 6 out of these 20 numbers. So we can also do 1 times 2 out of 20, plus 2 times 5 out of 20, plus 3 times 1 out of 20, plus 4 times 4 out of 20, plus 5 times 3 out of 20, plus 6 times 5 out of 20. And we add them up. So each number value times the relative frequency and add them together, we get 3.8. And that's the same as the average before. So that's a different way to calculate average for each different value. So we have 1 2 3 4 5 6, 6 different values, and multiply each value by its relative frequency and add them up. So that's also 3 average. And you can see the formula, this formula, instead of adding all the numbers up, divide by 20, the sample size, we calculate this way. We multiply each value by its relative frequency, corresponding relative frequency, and take sigma, which means do the addition. Sigma means addition, the sum. So we sum them up, we get 3.8. So that's a different way. And we're going to use this way if we know the value and its corresponding probability distribution. So we can, because in this case, if we look at the number of heads in 3 tosses before, for 0 head, we know the probability is 1/8, and 1, it's 3/8. And so in this case, we don't have, because when we toss the coin, we have the number of heads. If you toss it 20 times, suppose we do this experiment, we toss the coin 3 times. So the first experiment we do, I toss the coin 3 times, and I record the number of heads I get. So maybe I got 0 head, and then I do it again, do the second experiment. I will toss the coin 3 times again, and then I record how many heads I get. Maybe I got 3 heads, and then I would do it again, toss the coin 3 times, and then I record how many heads I have. So one experiment here is tossing the coin 3 times, and then you will do it again, repeat this, tossing the coin, keep tossing the coin 3 times, 3 times, and record the number of heads you get out of the 3 tosses. So in this case, and you will have, if you do this experiment 20 times, you will have, say maybe 0, you may have maybe 0 head. Maybe the first experiment you have 0 head. Maybe the second time you got 3 heads. Maybe the third experiment you got 2 heads, and then 2 heads, and so on. And then we can of course do sample mean. You're adding all of them up, divide by how many times you do this experiment. And or see, this is because we can find out the probability distribution. So this is like, if considering you're tossing the coin, do the experiment infinite many times, the probability of getting 0 heads is 1/8. So if you keep doing this experiment, tossing the coin 3 times, keep doing this forever, and the probability of getting 0 heads is 1/8. So in this case, we can use the second formula, because in this case, you would do the experiment infinite many times. You won't have infinite many numbers for you to add up and divide by infinite many number times. So in this case, we use the second formula that we talk about here. Each value times its relative frequency, but in our case, it's the probability for the probability distribution. So value times probability and adding up. So it's very similar to the sample mean. This is for the sample mean. You have 20 numbers, so each of them is called relative frequency, and you multiply the value and the relative frequency adding up. And in our case, it's the probability. So the probability is like you're doing the experiment infinite many times. So each value times its probability and adding up. So very similar to that one. So we can look at this example, how to find the mean. We will call this a population mean, or we also call it expected value, or you can just say expectance. So what we do is, by the formula, each value times its corresponding probability. So 0 times 1/8 plus 1 times 3/8 and plus 2 times 3/8 plus 3 times 1/8, and that will give us a summing up. So that will give us the population mean. So you can see we use a different letter. For sample mean, we use X bar. You have 20 data or 100 data, but for sample mean, you're considering you have infinite many data, and so we have to do this way. So multiply 0 and 1/8, 1 and a third, and then when we get, so each x value times its corresponding probability f of x, you get those numbers, and you adding up, you get 12/8, which is 1.5. So mu for population mean. So that's the first formula we talk about. And now we talk about variance. Recall the formula we had before, sample variance. If we have n data, n observations, we add all the squared deviations, divide by n minus 1. So we found sample mean first, subtract it from each value and square it to get rid of negatives, and adding up and take the average, divide by n minus 1. And what about the variance and the standard deviation of the random variable, if we know its probability distribution? So the formula will be different. Again, we do, this is not, we don't have 20 numbers, we have Imagine you are doing the experiment infinitely times, so you will have a probability distribution. And so the formula is still kind of similar. We don't use x bar. If you look at the formula before, you are doing each x value minus x bar, and that's the sample mean. But we know the population mean we use is mu, and it's sort of like average, but it's population mean, not sample mean. So it's for the entire population. So each value minus its population mean, and again square it, get rid of negative, and times its probability. So probability here it's already like relative frequency. You don't have to divide by m minus 1 anymore, because this is sort of already like the average there. And again, we use the symbol we use for population variance is sigma squared. So not s squared. S squared is the sample variance. So sigma squared is the population variance for entire population, not for a sample. And the standard deviation, so this is the population standard deviation. Again, that's the same. You take the square root of the variance, the population variance. So we can look at example. Suppose we have x value for the and this, and its corresponding probability distribution. So that you could have we can get this from some experiments and some surveys, and then in order to use the formula to find out the variance, by the formula we need to find out population mean first. And remember, the formula for population mean is here, each value times its corresponding probability adding up. So that's what we do first to get the population mean. So multiply each value and its corresponding probability. You get a 0 times 0.1 is 0, 1 times 0.2 is 0.2, 2 times 0.4, 0.8, 3 times 0.2, 0.6, 4 times 0.1, 0.4, and add all of these number up. That's the population mean. So you don't have to divide any n anymore, because you have infinite number. N is infinity, you cannot divide by n. And then you subtract each value x from this mu, population mean. So 0 minus 2, negative 2, 1 minus 2, and 2 minus 2, 3 minus 2, 4 minus 2. You get those values. And square all of them to get rid of negatives. And then you will multiply each of them by its corresponding probability. So take this column, multiply by f of x probability. So it's 4 times 0.1, 1 times 0.2, 0 times 0.4, and 1 times 0.2, and 4 times 0.1. And adding up, that gives us the population variance. So that's the formula again. So you will follow this example, do step by step. And then we will, so that's the variance, or you can say population variance 1.2. In order to get standard deviation, you take the square root of 1.2, and that gives us the standard deviation. And there's again, like a sample standard variance, we have alternative formula. Similarly, we have alternative formula for the population variance here. So we have, instead of doing x value subtract mu, we take the square of each x value and then multiply its corresponding probability and adding up, and minus the population mu squared. So let's look at the example again. Another so in this case we will multiply square, we will, instead of doing x times f of x, so we do x squared times f of x. So when we still have to do x times f of x in order to get the population mean, this is the same as before. Each x times its corresponding and adding up, get a population mean, and then we take x squared. Be careful, it's different from this column. We square each one to get a 0 square, 1 square, 2 square, 3 square, 4 square, and times its probability. So that's what we get. And then we adding up, we get a 5.2. And we take 5.2, look at the formula, take 5.2 minus mu squared. So that's what we do. Look, this is the formula. We this is 5.2 is what we get. Adding up, subtract mu squared, we use 2, and we get 1.2, the same as before. And standard deviation, take square root of 1.2, we get the standard deviation. So that's the sample variance. I'm sorry, the population variance. That's the population standard deviation.